Hello, very good evening. The students who have joined, kindly can you let me know in the chat box if my voice is audible and the screen and video is visible. Okay, and is the PPT visible? Okay, thank you very much. We will wait for a few minutes and then we will start our class. Okay. Okay, so very good afternoon to every students who have joined the class. My name is Moshumi Dev and I'm a PMRF fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. So I hope my voice is clear and the screen is visible to you. Okay, so at any point if you cannot hear my voice properly or cannot see the PPT properly, please do write in the chat box. I will just adjust everything again. So today it is the week 5 live session for the course Medicinal Chemistry, where we will discuss the problem related to your week 6 course assignments. And today the topics which we will cover, it is in your week 6 topics. So let's start the class. We can just wait for 2 to 3 minutes again to see if any more students will join, otherwise we will start. Okay. And at any point of the session, if you have any doubt, any problem, you can write in the chat box at the end of the session, or in between I will try to just answer those doubts also. And at the end of every question, try to solve the question, so it will be better to have a one-to-one interaction with you all. So I think we can just we will start after 2 minutes. Okay. Okay, let's wait for some time. I think more people will join, then we can start the session. So today the topics which we will discuss are basically based on the drug discovery and the metabolism part also. Few questions which will be out of the previous year's questions, so few questions will be new for you, but if you can solve them, I think it will be better for you also to learn some new things, not only from the previous years. So let's see how the class goes on. Okay, so I think we can now start, and if more students join, I will just add them into the class. So okay, my voice is clear and the PPT is visible to you, right? Please let me know in the chat box if my voice is not clear, and or if you have any problem seeing the PPT. So I will then start. Okay. So the first question, the problem number 1 of today's section is, which of the following statements is true regarding the Lipinski's rule? Number A, log P less than 5. Number B, molecular weight greater than 500 Dalton. Number C, hydrogen bond donor greater than 10. And number D, hydrogen bond acceptor equal to 20. So there is a very important and very famous rule regarding the drug discovery, which is called the Lipinski's rule. So it is said that when you are designing a compound to be a drug or a drug molecule, so you have to follow this Lipinski's rule, or very famously it is known as Lipinski's rules, or rule of 5. So this rule is basically about a compound which have some characteristic to be a more drug like. Okay, so you have to identify which of the following statements is true regarding this Lipinski's rule. Your options are: number A, log P less than 5, number B, molecular weight greater than 500 Dalton, number C, hydrogen bond donor greater than 10, and number D, hydrogen bond acceptor equal to 20. Okay, somebody wants to join. So do we have any answer? Okay, so for after every question, try to solve the question. Okay, you can just write the question in the chat box. If you write the question in the chat box, I will just check, and after I will show you, after that I will show you the answers. Okay, so first you try to solve the question, and then I will just show you the answer, and we will discuss this thing in more detail. So do we have any answer for it? Okay, so we have one answer, option A. So let's see. Okay, So it is correct. The true statement regarding the Lipinski's rule is number A, log P less than 5. Okay, so now we will discuss it in detail. Okay, so Lipinski's rule of 5. So this rule, it says that for a compound to be drug like, it should follow 4 rules, and these rules known as Lipinski's rule of 5. So what are these rules? As we can see, the rule is not more than 5 hydrogen bond donor. Now what is hydrogen bond donor? So basically the hydrogen bonds donor in the drug like compound or anything, it is basically the hydroxyl group or the amine group, okay, the OH and NH2 groups, like the OH and NH2 group. These are mainly or NH2 group or NH. Okay, so basically hydrogen which is bonded with oxygen or nitrogen, these compounds are called the hydrogen bond donor. Okay, why hydrogen bond donor? Because this hydrogen, it has a delta positive charge. Okay, since it has a delta positive and this oxygen has a delta negative charge because of the difference of the electronegativity. So this compound, when there is another say oxygen or negative charge something, so what will happen? There will be a hydrogen bond formation. Okay, since these functional groups, these are given this hydrogen atom for the hydrogen bond formation, these are called the hydrogen bond donors. So a compound to be a drug like, it should have not more than 5 hydrogen bond donor and not more than 10 hydrogen bond acceptors. Now what are hydrogen bond acceptors? Like I have said here, there is a if there is a O minus, okay, or there is a ketone type of group. So these groups which can actually form a hydrogen, which are partial negative charge and which can bond a hydrogen bond with this partially positive hydrogen atom. So these are called the hydrogen bond acceptors. Okay, so not more than 10 hydrogen bond acceptors should be present in the compound or the molecule. So and the molecular weight, it should be less than 500. So here where we now have said that the number option number B, it says that molecular weight should be greater than 500, so it is not correct. Number C, we have said that hydrogen bond donor should be greater than 10, it is also incorrect. And number D, which we have said that hydrogen bond acceptor is equal to 20, this is also incorrect. So these 3 options are incorrect. So and the 4 characteristic which is called the characteristic regarding the lipophilicity, which is C log P or log P not greater than 5. Okay, so P log P should be less than 5. Now what is this P? P is nothing but is called the partition coefficient. So it is a measurement of the drug water solubility. Okay, so partitioning means the drug will be divided into the part between the water and oil layer. Okay, so P or partition coefficient equal to concentration in organic layer divided by concentration in water layer. So log P, it will be log C0 or CO divided by CW. Okay, so log P, if it is greater than 2, then it is a lipophilic drug, means the drug has more solubility in the oil part rather than the water layer. And if the log P is less than 2, so it is called a hydrophilic drug. Hydrophilic drug means the drug has more solubility into the water part rather than the lipid part. Okay, so log P only applied for the neutral compound. Okay, so ionic compounds, it does not have this log P, only neutral compounds have this log P value. Okay, low log P means low penetration in the CNS, okay, which is the central nervous system. And high log P, the low water solubility, not suitable for the oral administration. So if a compound or if a drug have a very high value of the log P, means it has a very low water solubility, means it is not suitable for the oral administration. You cannot take the drug by your mouth or taking by using the water, you have to take it in the intravenously. Okay, but there are few examples which are the exception of this rule. Okay, so not all the drug molecule or all the medicinal compound, it will follow the Lipinski's rule. So there are few exception, which is this paclitaxel, which is a natural product, which is a very important anti-cancer drug. All you have heard of, like Taxol. Okay, so there is this kind of evermectin or vincristine. So these are these natural products which are the exceptions of this Lipinski's rule of 5. Okay, so I think you have understood the Lipinski's rule. So do you have any problem understanding these things? If you have any doubt, any problem at the point of this lecture, so please do write in the chat box. Okay, at the end of the session or in between, whenever I have time, I will just check those doubts and I will just try to clarify the doubt. So it was your problem number 1 of today's session. Now I will move toward the problem number 2, if it is okay. So problem number 2, it says that which of the following statements is the closest description of phase 1 metabolism? Number A, reactions which water in the blood supply. Number B, reactions which add a polar functional group to a drug. Number C, reactions which occur in gut wall. And number D, all of this. So you have to identify the correct description or the closest description of the phase 1 metabolism. Now the metabolism can mostly be in two types. The first one is the phase 1 and again is the phase 2 metabolism. Now you have to identify which is the closest description of the phase 1 metabolism. Number A, reactions which occur in blood supply. Number B, reactions which add a polar functional group to a drug. Option C, reactions which occur in gut wall. And option D, all of this above. Okay, try to answer this question. Which one of you think is the correct answer? So it does not matter if your answer is correct or wrong, okay, because at the end of the every question I just discuss the answers and I discuss which is the correct way of answering this. But if you try to answer it, it will be better, because in that way you can learn, or at least you can if you can try, maybe you are wrong, but still it is better to have this kind of interactive session. Otherwise it is there is no point, right? So please try to answer this question. Which of the following statement is the closest description of the phase 1 metabolism? So do we have any correct answers or any answers? Okay, not till now. Okay, I will show you the answer, then we will discuss about the phase 1 metabolism. Okay, so the correct answer is number B, reactions which add a polar functional group to a drug. Now phases of metabolism. So in phase 1 there are functional reactions. Okay, and so for the functional, okay, so in the phase 1 there is a functionalization reactions, like it converts the parent drug into more polar metabolite by introducing or unmasking a functional group like OH, NH2, SH. Okay, and the phase 2 metabolism, it is the conjugation reactions, means subsequent reaction in which a covalent linkage is formed between functional group on a parent compound or phase 1 metabolite and the endogenous substance such as the glucuronic acid, sulfate, acetate or an amino acid. So metabolism or biotransformation, the phase 1 and phase 2 reactions overview. So phase 1 reactions often make the drug sufficiently polar that it can be excreted. Okay, however, the phase 2 reactions often required whereby a conjugate is added or covalently linked, such as amino, a glucuronic sulfuric acetic acid, to make the drug even more polar, charged or hydrophilic. So conjugation often occurs at the functional group location, right? So this is a parent drug. So after the phase 1 reaction, what will happen, like this parent drug, it is connected to a functional group which is a polar functional group, okay, like having OH, NH2 or SH. Now what will happen after this phase 2 reactions, what will happen, this functional group, it is connected to a conjugate, and now this conjugate, it may be or it should be a endogenous substance, okay, and although the phase 1 reactions usually occur before the phase 2 reaction, sometimes in order is reversed, okay, and phase 2 reaction can occur alone also. Like the parent drug, it can pass through the phase 1 reaction when more polar metabolite is pharmacologically uncharged, inactive, or enhanced or otherwise modified, okay. Now and then it can go to the phase 2 metabolism, or then it can go to the elimination, or this phase 1 metabolite can also be eliminated at first, or what can happen, like this parent drug, if it is lipophilic enough, so it can directly go to the phase 2 metabolism without passing through a phase 1 part, and in this way it will be after that it will be eliminated. So what happens when a drug is given, so it means mostly it is the lipophilic one, and in this through metabolism, when passing through the phase 1 phase 2 metabolism, what will happen, this lipophilic compound will transformed into the more hydrophilic one, and then this hydrophilic compound is very easy to be eliminated, okay. So basically the overview is of the phase 1 metabolism is, you are giving a compound as a drug, and what will happen in phase 1 metabolism, there will be functionalization reactions which will add some polar functional group to this drug, okay, so that the drug can react further with some endogenous compounds, and this is called the phase 2 metabolism, and after that the metabolites which will follow form, it will be eliminated easily, okay. So this was all overview of your phase 1 and phase 2 metabolism. So the correct answer of this problem, which is the following statement, which is the closest description for the phase 1 metabolism, is number B, the reactions which add a polar functional group to a drug, okay. So I think it is clear. Do you have any doubt regarding this problem? Okay, I think it is so if you have any doubt, as I have said earlier also, if you have any doubt, if you do not understand any point regarding any question or anything, so you can just always write in the chat box, okay. I will just try to answer those query at the end of the question or at the end of the session if I missed something in between. So I will definitely try to answer those, but please try to answer the questions, okay. When I am saying some question, please you try to answer the questions. It may be wrong, maybe right, does not matter, but if you try to answer, I think it will be better, okay. So I think the problem number 2 is okay with everybody. Then I will move toward the problem number 3. Okay, so the problem number 3, it says that phase 2 metabolism occurs mainly in, the options are number A, liver, option B, lungs, option C, kidney, and option D, gut. So in previous question we discussed about the phase 1 and phase 2 metabolism. Now this question is related to the phase 2 metabolism, and it is said that the phase 2 metabolism, it occurs mainly in liver, lungs, kidney, or gut. So you have to identify the correct body part where the main phase 2 metabolism occurs. Try to answer this question in the chat box. Okay, so do we have any answer correct for that? Okay, we have one answer which says liver. Okay, let's check if it is correct or not. Okay, so it is correct. The correct answer is the liver. So what are the phase 2 reactions? So phase 2 metabolites are attachment of small polar endogenous molecules such as glucuronic acid, sulfate or amino acid to the phase 1 metabolites or parent drugs. So products are more water soluble and easily excretable. Trapping highly electrophilic molecule with endogenous nucleophiles such as glutathione prevents the damage to important macromolecules such as DNA, RNA and proteins. So regarded as a true detoxifying pathway with few exceptions, and in general appropriate transferase enzyme activate the transferring group like glucuronate, sulfate, methyl acetyl in a coenzyme form. Okay, so these are basically about the phase 2 reactions. Now this is a very nice flow chart regarding the metabolisms. So this is a drug molecule. Okay, so what will happen, this in phase 1 part the oxidation is mainly takes place like by cytochrome P450 enzymes, and in via phase 2 what happened, like conjugation. Okay, and the stable compounds are formed. So this a drug molecule can pass through phase 1 and then phase 2 conjugation to make a stable product, or it can also pass through the directly to the phase 2 metabolisms. Okay, so what will happen, this metabolites which are getting transformed by the phase 1 metabolism, these are polar species. Okay, and it will transfer to the kidney for the renal elimination via urine. Okay, but the phase 2 metabolism and the metabolites which are mainly the non-polar species, and what happens, like they are eliminated by the liver. Okay, the metabolism will takes place in liver and it will be eliminated by the biliary elimination, means via stool. Okay, so this is the about the phase 2 and phase 1 metabolism. So one more thing, that this PPT and everything it will be shared to you. Okay, so don't worry if the screen is not much visible or there is something like a blur. If you can check the PPT from the link which will be shared to you by the NPTEL website, and there you will find all the things are more clear. Okay, so I think this part may be little bit hazy, but when you will see from the PPT itself, so it will be clear to you. Okay, so this was all about the phase 2 metabolism. What are the phase 2 metabolism reactions and where it happens, like it happens in liver, and this is all about. So now I will move toward the next problem. Okay, so problem number 4, it says that sulfation is an important method of detoxification of xenobiotic. Which of the following acts as a source of sulfate? Number A, hydrogen sulfide. Number B, methionine. Number C, sulfuric acid. Number D, phosphoadenosine phosphosulfate. So as I said that the sulfation is one of the important method of detoxification of xenobiotics, and it is also one kind of you can say that phase 2 metabolism. So which of the following acts as a source of the sulfate? Options are hydrogen sulfide, methionine, sulfuric acid, phosphoadenosine phosphosulfate. Okay, so somebody I think have raised the hand. So if you have any query, anything, you can write in the chat box directly. Okay, because I have make the host controls like it, like you can just answer the questions and anything by the chat box. It will be easier in that way. So if you have any query, any doubt, if you want to say anything, you can write in the chat box. Okay, so try to answer this question. Okay, I will show you the answer. So do we have any answers for it? Otherwise I will just discuss this. Okay, we have one answer which says number D. Okay, let's check if the answer is correct or not. So see, it does not matter if the answer is correct or wrong, but to answer a question it is very important. So yeah, very good, it is the correct answer. The correct answer, like the source of the sulfate is the phosphoadenosine phosphosulfate. So this is the phosphoadenosine phosphosulfate. Okay, this compound, this is your, so here you can see like there is a adenine kind of unit. Okay, then there is a sugar moiety, and then there is a phosphate type of group. So what happens, like this phosphoadenosine phosphosulfate synthesis. Okay, so it is a one pot chemoenzymatic reaction. So what happens, so there are sulfates. Okay, and the sulfate, it is converted to APS, or adenosine 5 phosphate, okay, from 5 prime phosphate by ATPase, and one ATP molecule, it is giving like 1 phosphate, and after this polyphosphoric acid, it is converted to 2 phosphate molecule, and this compound, it is converted to this phosphoadenosine pyrophosphate by this enzyme SK, and one ATP molecule, it is converted to ADP molecule. Okay, and then what happened, like this phosphoadenosine phosphosulfate regeneration system coupled with the chemoenzymatic synthesis of sulfated polysaccharide. So the one substrate, it is the main reaction actually. So there is a substrate, and it will be converted to the sulfated product, and the source of sulfur is this phosphoadenosine phosphosulfate. Now there is a HS or HP sulfotransferase enzyme, and from this phosphoadenosine phosphosulfate, now it is converted to PAP, and then this PAP is regenerated to this phosphoadenosine phosphosulfate by this enzyme AST4 enzyme. Okay, and in this way there is a p nitrophenol sulfate which is converted to the p nitrophenol, and this sulfate paranitrophenol sulfate is converted to paranitrophenol, and the sulfate group is transferred to this PAP, and it is regenerated by this PAPS. Okay. So this was, so just remember, so you don't need to remember this complicated PAPS regeneration and synthesis circle. So I have just give you this brief so that you for your knowledge, but it is not necessary for you to remember or memorize this thing. Okay, so just you remember, if you remember the structure of this phosphoadenosine phosphosulfate, it is good. Okay, and remember, it is the source of the sulfur in the body. Now I will move toward our next problem. So problem number 5, it says that which of the following isozymes is most important for drug metabolism? Number A, CYP2C9. Number B, CYP2D6. Number C, CYP2E1, and number D, CYP3A4. So you have to identify the most important isozyme for the drug metabolism. The CYP2C9, CYP2D6, CYP2E1, or CYP3A4. So I think we have some answer. Okay, again I have said, if you have any doubt, anything, please write in the chat box. If you want to answer the question, you can write in the chat box. Okay, or if you have any doubt, you cannot hear my voice, or you cannot see the PPT properly, everything should be the issue, anything should be raised in the chat box. Okay, so if you want to answer, student who have just raised the hand, so if you want to answer the question, you can write in the chat box, or others also may try to answer this question. Okay, so I will discuss this part also. So the correct answer means the most important isozyme for the drug metabolism is CYP3A4. So CYP means the cytochrome P enzymes. So what happened, like these enzymes, isozymes are very important for the drug metabolism. All the isozymes which are mentioned in this question or these options, which these are important for the drug metabolism, but the 3A4 is the most important one. Okay, so as you can see, that this is a kind of this diagram. So from this pie chart, okay, so here you can see that CYP3A4 or 5, it is has the most important, or it has the most percentage of in the human body, like 30.2%. okay, then after that we have all these other enzymes like CYP2D6. it is also very important because it has up to 20%. CYP2C9, it is for 12.8%, and CYP there are others also, okay, like 1A2. so these every isozymes have some different roles in the body, but this most important for drug metabolism, the CYP 3A4 is the most important. So as you can see that these isozymes have few cardiac substrate and strong inhibitor or inducers also, like it has like amlodipine, felodipine or nifedipine, amiodarone, and these are all atorvastatin, and these are all the cardiac substrate for this. And the strong inhibitors like are the grapefruit juice, erythromycin, itraconazole, ketoconazole. So these are these azoles are very antifungal agents, and strong inducers like carbamazepine, rifamycin, and this all. okay, so this you don't need to remember or memorize everything, but remember the name of this isozyme like CYP3A4 because it is a very important isozyme for the drug metabolism. Okay, so it was the problem number 5. So again I am saying, if you have any doubt, anything, please write in the chat box. okay, and please try to answer the questions, because otherwise it will be very problematic for me to understand if you have understood the part or not. okay, so I will move toward the next problem. So problem number 6, it says that which of the following is the main organ for the drug excretion? Number A, lungs, number B, liver, number C, kidney, and number D, sweat glands. So you have to identify which of the following is the main organ for the drug excretion. The options are as follows: number A, lungs, number B, liver, number C, kidney, and number D, sweat glands. So try to answer this question and write the answer which you think is correct one in the chat box. Okay, somebody has given answer number B. Okay, let us check if it is correct or not. As I've always said, okay, others also try. As I always have said, like it doesn't matter if the answer is correct or wrong, but if you try to answer, it will be better for you only. So others also try which is the correct answer. Do you think? Somebody have said number C. So we have mainly two answers for this question, number B and number C, and let's check out which one is the correct one. Okay, so correct answer is number C, kidney. Okay, so excretion is defined as a process whereby drugs or metabolites are irreversibly transferred from internal to external environment through the renal or non-renal route. Okay, So excretion along with the metabolism and tissue redistribution is an important determining both the duration of the drug action and the rate of the drug elimination. And the renal excretion, drugs are eliminated from the body primarily by the kidneys, and the principal renal mechanisms that are involved in the excretion of the drugs is the glomerular filtration, active tubular secretion and active tubular reabsorptions. So this is the flowchart for the renal excretion of the drug. So first what happened, like there is a glomerular filtration of water, unbound drug and metabolites. Number 2 is the active tubular secretion, acidic basic drugs and metabolites. Number 3, active reabsorption as acidic basic endogenous compounds and passive reabsorptions, lipophilic drugs. And urinary excretion, drugs and metabolites that are filtered and actively secreted and non-reabsorbs. Okay, rate of excretion equal to rate of filtration plus rate of secretion minus rate of the reabsorptions. So which it is the rate of the excretion, which is the rate of filtration plus rate of secretion minus rate of reabsorption, and it is the figure for the urinary excretion of the drug. As you can see, like blood, it is going on from this passage to this passage, okay, and there is a glomerulus and there is number 1, 2, 3 and then there is a 4, okay. So it is an irreversible transportation of a drug and their metabolites from body to the outer environment. So the main organ for the drug excretion is the kidney. So in liver, the main metabolism part happens in the liver actually. So as you have said in the previous slide, like the liver, it main metabolisms and mainly phase 2 metabolism, those are taking place in the liver, and the excretion, drug excretion is the mainly is taken care of by the kidneys, okay. So anyway, it does not matter if the answer is correct or not, but at least you are trying, which is very important here at this kind of classes. Okay, so I think it is clear to all. If you have any doubt, anything, you can write. Okay, we will next move toward our problem number 7. Okay, so problem number 7, it says that selegiline is a specific inhibitor of number A, myo B, number B, myo A, number C, acetylcholine, and number D, ACE. ACE is the basically angiotensin converting enzyme, and myo A, myo B, these are also enzymes, okay. And you have to identify, like selegiline is a specific inhibitor of the which enzyme. Try to answer this problem. I will discuss it in detail again, but at first if anybody wants to answer it, you can just go ahead and try to answer in the chat box. Do we have any answer for this question? Okay, we have one answer which says myo B. Okay, let's check. Okay, very good. So the correct answer is myo B. Now what is this enzymes? So this enzyme, it stands for the monoamine oxidase and monoamine oxidase, okay, and monoamine inhibitors, oxidase inhibitors. So what is the first, let us see what is this myo A and myo B. So these are called the monoamine oxidase enzymes, okay. Now these monoamine oxidase enzymes or myo enzymes are of two isotypes. The first one is the myo A enzymes, which are present in the cytoplasm of the neuron, that means the central nervous system, CNS, and the peripheral tissues, for example liver, and it acts non-specifically on Na, 5-HT and dopamine, and chloroglyline is a specific inhibitor for the MyoA and MyoB enzymes. So these are present mainly in CNS and acts more on dopamine, and serotonin is the specific inhibitor for the MyoB and paraglide is the non-selective for MyoI. Somebody wants to join, I think. So okay, so what are the this inhibitor for this myoenzymes? So monoamine oxidase inhibitors or MyoI inhibitors are a class of powerful antidepressant drugs. So they are particularly effective in treating the atypical depression, panic disorder, social phobia. Due to the potentially lethal dietary and drug interaction, MyoIs have been reserved as a last line for the RX, used only when other classes of antidepressant drugs like SSRIs and TCS have failed. Okay. So this monoamine oxidases are a particular kind of enzymes which basically have the substrate as this dopamine or something on central nervous systems. Okay, and the inhibitors which of the for this enzymes which are called the monoamine oxidase inhibitor or inhibitors, they are basically a powerful class of powerful antidepressant drugs which are particularly effective in treating the atypical depression or panic disorders, but these have a very lethal dietary and drug interaction. Okay, that's why these are the last options for the antidepressant drugs. So there are other classes of antidepressant drugs. So first those are tried during the this depression treatment, but if those drugs do not have any effect on the patient, then this kind of inhibitors are recommended. Okay, so so what you have to remember in this part, like there are mainly two kind of enzymes for this monoamine oxidase or myoenzymes. Number A is MyoA and then is MyoB, and a few examples for this inhibitors and what this substrate of the both enzymes. So you have to remember these few things regarding these enzymes. Okay, so till now do you have any doubt regarding this question or this problem? I will move toward our next problem then. Okay, so that's how try to answer the questions. Okay, because otherwise it won't be any fruitful class if you don't answer the questions. Okay, so again I will move toward the next problem. Okay, the problem number 8, it says that alkenes and aromatic groups can be metabolized to diols. Which enzymes are involved in this kind of reactions? Number A, cytochrome P450 enzymes. Number B, epoxide hydrolase enzymes. Number C, both of the above. And number D, none of the above. So this is a kind of a very easy and tricky question also. So alkene and aromatic group can be metabolized to diol. You have to identify which of the enzymes are involved or which is the enzyme which is involved in this reaction. Is it cytochrome P450 enzyme or epoxide hydrolase enzyme? Both of the above? None of the above. Try to answer it in the chat box. Okay, we have one answer. Actually, we have two answers, both and number C. So both answers are about like both are the correct. Okay, let's check. Okay, very good. So the correct answer is number C, both of the above. Okay, so cytochrome P450 enzymes, actually these enzymes are involved in many reactions, many functionalization reactions. So these are involved, like they can add hydroxyl OH. So mainly the role of this cytochrome P450 enzyme is to add one oxygen atom or OH group to a substrate. So as you can see, like there is a amine, so it will be converted to a NOH bond, okay, amine alcohol kind of. So if there is cyclic alkane, so it will be converted to this kind of alcohol. So basically alcohols, or if there is a sulfur group, okay, thioketone, it will be converted to ketone. So basically these enzymes actually uh, transfer oxygen atoms to the substrate. So as you can see, if there is a diene, okay, alkene, and there is a, or there are aromatic groups, so what will happen, like these are converted to the diols, okay, and also the alcoholic phenol, like phenol kind of group, okay. So and there is another enzyme which is called the epoxide hydrolase. So what this epoxide hydrolase do, like this epoxide hydrolase, it converts the aromatic group and to the thiol. So there is, if there is a epoxide, so this epoxide hydrolase has this aspartate kind of functional group, and this aspartate, it will be attacking on this epoxide carbon, and this carbon oxygen bond will be broken, and there is a proton, and what will happen, like there is this ester intermediate is formed, okay, and then what will happen, like after the hydrolysis, this ester is formed to the dihydrodiol, okay. So this is the complete reaction for this epoxide hydrolase, and the reactions which takes part the cytochrome P450, it is little bit complicated, but you remember the examples, okay. So what can this questions can come in this part also, like you are given a particular transformation, like from this to this, and you have been asked to write the name of the enzyme, okay. So maybe another transformation has been given to you, like from this thioketone to ketone, and you have been asked to write the name of the enzyme. So remember, it is the cytochrome P450. It is a very important enzyme, okay. So I think it is clear. Then problem number 8. Now I will move toward the problem number 9. So problem number 9, it says that which metal ion is present in the active site of cytochrome P450. Like in the previous question, I have discussed about the cytochrome P450 and the reactions which is being catalyzed by this enzyme. Now you have to identify which metal ion is present in the active site of this cytochrome P450. Options are number A, magnesium, number B, nickel, number C, zinc, and number D, iron. Try to answer this question in the chat box. Which of the metal ion you think is present in the active site of cytochrome P450? Okay, we have one answer, iron. Others also try if you think it is correct, or do you think other metal ion is present? Okay, somebody have said magnesium. So we have 3 magnesiums and 1 iron. So let's check which is correct answer. Okay, so correct answer is number D, iron. So as I have said, this cytochrome P450 is a very important enzyme, okay. Why? Because it takes part in many metabolisms in our body, like in xenobiotic metabolism, for example CYP81 A metabolize several herbicides. In hormone regulation, like CYP707 ABA hydroxylase ABA catabolism. Secondary metabolite biosynthesis, like CYP79A during biosynthesis. Plant defense in hypersensitive rapid cell death. Antioxidant biosynthesis, like CYP75 in flavonoid 3' 5' hydroxylate, and fatty acid metabolism, like CYP86A2 in omega hydroxylation in chitin biosynthesis. So these are the some metabolism or reactions in which the cytochrome P450 takes part. Okay, and the other reactions were in the previous slide which we have noticed. So the active site of this cytochrome P450 enzyme, it contains iron. Okay. So the active site, it contains iron. Okay, so this is a very a short diagram, because this is a little bit complicated for the mechanism for cytochrome P450, but I will try to let you know. So this is called a porphyrin ring. Okay, as you can see, this kind of ring which is called the porphyrin ring. Okay, or the heme protein. So this this is a heme kind of enzyme, and in the center there is a iron 3. Okay, so this iron 3 is the in the active site. Okay, and the proximal end, it has a cystenyl sulfur. Okay, and this is what happens. So first oxygen will come, and in presence of NADPH, so what will happen, and the thiol is the substrate. So this is the overall reaction for the cytochrome P450. So if there is a thiol like SH, let's say, so what will happen, this will be like SOH, means one oxygen will be added in this substrate. Okay, and this is the active species by which the active intermediate, you can say, which is the iron 4 cation radical. Okay, and this is a double bond oxygen, and there is single bond sulfur, and this sulfur is from the cysteine. So what will happen, like at first oxygen will be added here, and there is a NADPH, and what will happen, will be a electronic push. So the iron is in the iron 3 state, and one electron will be given to this oxygen, and this OO bond will be broken. Okay, and what will happen, like there will be a Fe double bond O bond formation, and there is a cation radical. Okay, and there is a electronic push here, and what will happen after that, this cation radical, it will be giving it will forming this kind of radical. So this will attack this hydrogen, and sulfur radical will form, and after that what will happen, this sulfur will attack the oxygen, and the SOH bond is formed. So it is a overall reaction. Okay. Yeah, the slides will be shared to you after the class. Okay, so after every week's class, I share the slides with the NPTEL site, and they will share this slide and this lecture video of today's class to you, and after the class. Okay, so in due time it will be shared to you, you don't need to worry about it. So this was all about the cytochrome P450 enzymes, the active site, and how the reaction takes place. Okay, so the course of the reaction overall, so you don't need to memorize this. Just remember, the active site, it contains iron, and what does this enzyme do, it basically adds one oxygen to this substrate. Okay, and this oxygen, it comes from the dioxygen, and NADPH is a coenzyme for this reaction. Okay, and the active intermediate, it contains iron 4 cation radical. So this was the overview for this cytochrome P450 enzyme. Okay, now I will move toward the next problem. So problem number 10, it says that some orally active drugs have molecular weight greater than 500, thus disobeying the Lipinski's rule of 5. What is the mechanism behind this? Options are number A, phagocytosis, number B, absorption through gut wall, number C, pinocytosis, and number D, ion channels. So as in the first question for this today's session was about the Lipinski's rule of 5, and there was one rule, like the molecular weight should be less than 500. Okay, but some exceptions which we have seen in that slide, like there are some drugs which have molecular weight greater than 500, or does not obey this Lipinski's rule, other rules, but it is still bioactive. Okay, so some orally bioactive drugs have molecular weight greater than 500, but what is the mechanism behind this? Your options are number A, phagocytosis, number B, absorption through gut wall, number C, pinocytosis, and number D, ion channels. Try to answer this question. What you think is the correct mechanism, and write in the chat box. Okay, we have one answer is number C, pinocytosis, and somebody have says number B. Okay, let's check which is the correct answer. Okay, so the correct answer is number C, pinocytosis. So what is pinocytosis? So pinocytosis is a process by which liquid droplets are ingested by living cells. Okay, pinocytosis is one type of endocytosis, the general process by which the cells engulf external substances, gathering them into a special membrane bound vesicle contained within the cell. Okay, so as you can see, there is a pinocytosis, there is a diagram. Okay, so the solutes bind to the cell membrane, these are the solutes or the external drug molecules, let's say. And what will happen, this is the cytoplasm, this is the nucleus, and this is the pinosome. And what will happen, this is the cell. Okay, so first the solutes bind to the cell membrane. Okay, and then what happened, like the cell membrane starts to fold inward. Okay, and there is a inward kind of this hollow type of shape where the solutes will attached. Number 3, the cell membrane continues to fold, and number D, both ends of the fold meet producing a pinosome, and this pinosome has this external molecules. Okay, so this is the pinocytosis, that's how it works. Okay, now what is the phagocytosis? The phagocytosis is the bringing solid particles to the cell. Pinocytosis, it is the bringing the liquid particles into the cell. And there is one more thing which is receptor mediated endocytosis, bringing in the particle attached to the receptors on the cell membrane. So pinocytosis, it is the form of the endocytosis where the external molecules are engulfed into the cells, okay, and by the special membrane bound vesicle, which is called the pinosome for in case of the pinocytosis. Okay, so this was all about the pinocytosis. So the drugs which have molecular weight greater than 500, they become orally active by this mechanism of the pinocytosis. Okay, so this was your problem number 10. Now let's check out the problem number 11. Okay, so the problem number 11, it is a quick maths actually. So it says, if a drug has a half life of 4 hours, how much of the drug stays in the body after 24 hours? Number A, 1.56%, number B, 50%, number C, 6.25%, and number D, 12.5%. Okay, so class, for this maths, so what I will do, I will just give you for few moments. Okay, I will give you like 5 minutes. Okay, it is a 5-minute break, and also it is a kind of time where you can try to do the math. Okay, so after 5 minutes I am here also. Okay, I will just turn off my camera for some time. So for 5 minutes you can take a break and try to solve this math. After 5 minutes I will join. I am here also. Okay, so I will rejoin, and then I will check the answers, and then we will move forward in the class. Okay, so I am not leaving the class. Okay, I am here, but I am giving you a 5-minute break, and try to solve the maths. After 5 minutes I will check the answers, and then we will proceed further. Okay. Okay, hello, welcome back. So have anybody tried to solve the answer for the problem number 11? So if a drug has a half-life of 4 hours, how much of the drug stays in the body after 24 hours? Okay, so we have answers like number A 1.56. Okay, let's check if what is the correct answer. Okay. Okay, so the correct answer is yes, number A, it is 1.56%. So this is the math. Okay, so it says that the drug has a half life of 4 hours, which means like in the 4 hours it will be of the half of its concentration. Okay, so say at the time of the administration the drug have the concentration of the 100%. So what will happen after 4 hours, it will be of the 50%. Okay, next what will happen in next 4 hours, mean total 8 hours, it will be of half of this 50%, it will be 25%. Okay, now in next 4 hours, mean in 12 hours it will be half of this, means 12.5%, and subsequently after 24 hours it will be in 1.56%. so it is the total calculation for the drug. So it is very easy. If you see the half life, so you have to just make it half one by one. Okay, so this is the problem number 11. Now quickly I will move toward the next problem. Okay, so the problem number 12, it says that which enzyme is involved in the activation of the prodrug cyclophosphoramide. Okay, so the options are number A SOD, number B cytochrome P450, number C cytochrome C oxidase, and number D MMO, which is methane monooxygenase. Okay, so you have to identify which one of the enzyme is involved in the activation of the prodrug cyclophosphoramide. Again, try to write the answer in the chat box. It does not matter if the answer which you are writing is correct or wrong, but at least you should try to answer this question. If you know, you should try. Okay, write the answer which you think is correct in the chat box. I will check and I will discuss it. Okay, so do we have any correct or any answer in the chat box of the problem number 12? Okay, there is one answer, number B. Okay, let's check out. Others can also try, if does not matter if the answer is correct or wrong. Okay, so okay, let's see which is the correct answer. Okay, very good. So the correct answer is cytochrome P450. So cyclophosphoramide, so this is let's check out the answer. Okay, so mechanism of action, cyclophosphoramide is the most commonly used alkylating agent. So both cyclophosphoramide and ifosfamide so are first biotransformed to hydroxylated intermediates primarily in the liver by the cytochrome P450 system. The hydroxylated intermediates then undergo breakdown to form the active compounds phosphoramide, mustard, and acrolein, and the reactions of the phosphoramide mustard with DNA is considered to be the cytotoxic step. So as you can see, like the cyclophosphoramide, so this is the cyclophosphoramide. Okay, And cytochrome P450 enzymes, so what these enzymes will do, so as we all know, these enzymes actually add the oxygen atom. Okay, so as you can see, like previous slides also, so there is the introduction of the hydroxyl group in this cyclophosphoramide. And what will happen next, there will be the ring opening, and open ring aldehyde form the alcohol non-enzymatically, and this is the phosphoramide, which is the phosphoramide mustard, which is the active one, and this is the acrolein, which is the toxic, and this is the reactive species. So it is the overall reaction how this happened, but you don't need to memorize anything of this. So this is only for your knowledge. I have just put up this mechanism so you can understand how the reaction work out. Okay, so remember this, the cytochrome P450 is the enzyme which is the involved in the activation of this prodrug of the cyclophosphoramide. Okay, now I will move toward the next problem. So problem number 13, it is also a math. Okay, and I want everybody to try this math by yourself. Okay, so problem number 13, it says that pK of the most acidic functional group of the antibiotic cefotaxime is 3.4. Okay, predict where it will be absorbed. Options are number A, stomach having pH of 1, number B, intestine having pH of 6, number C, in both, number D, in none. So you have to identify where this antibiotic will be absorbed, while the pK of this most acidic functional group is 3.4. Okay, so try to do this math, and I will show you how it is done and how which is the correct answer, but at first it will be better if you try to do this math by yourself. Okay, so take 2 minutes and try to solve. It is a very easy, just you have to look at the values carefully. So do we have any correct answer for problem number 13? I think till now not, there is no answer, but okay, try. I will give you 2 more minutes. Okay, so one more time I will check. If there is any answer, then I will discuss it. Okay, no problem. Please show the question on the screen. Okay, okay, so it is the correct answer for this question, and I will show you how it is being solved. Okay, okay, so the formula which we will use to solve this question is this: pH equal to pK plus log in first parenthesis the ionized concentration of ionized form divided by concentration of the unionized form. So can anybody say what is the name of this formula? What is the name of this formula? Do anybody know? If you know it, you can write in the chat box. Okay, after mentioning it I will just check. So what will happen in stomach? So we have the three values for our this math. Okay, first one is the pK of the drug, which is 3.4, which is the pH of the stomach, which is 1, and the pH of the intestine, which is 6. Okay, so in stomach what will happen? The pH equal to pK plus log ionized by unionized. If we put the values, so the pH is 1, pK of the drug is 3.4 equal to plus log this is the functional group, which is the most acidic, so the concentration of this carboxylate ion divided by the concentration of the carboxylic acid, means ionized divided by unionized. So if you just solve it out and take the antilog, so what will happen? The concentration of the carboxylate ion divided by the carboxylic acid will be 0.00398. So means the drug will remain as a whole rather than the ionized form. Okay, and in the intestine what will happen? The pH is 6 and pK is 3.4. Again the log of carboxylate ion divided by carboxylic acid, and the concentration of carboxylate ion divided by carboxylic acid is 2.6, means the drug will remain in the ionized form mostly. So unionized form of a drug can get a better access to the membrane, so it will be absorbed in the stomach. So as you can see, if you solve this, what will happen? Like the drug will remain in the ionized form in the stomach, and in the unionized form in the stomach, and in the ionized form means in the carboxylate form in the intestine. So since the neutral drug means the unionized form of the drug can get a better access of the membrane, so it will be mostly absorbed in the stomach, not in the intestine. And the formula which we are using, I have just asked you to, if you know the name of this formula, if you know, you can write in the chat box. Okay, and anyway I will come to you in the later. Yes, very good, it is the Henderson-Hasselbalch equation. Okay, so we are using this equation to solve this math. And did you understood how the math is done here, or did you understand how we solve this problem? If you don't understand, please tell me right now, I will repeat once more. Okay, so do I need to repeat how the math is solved, and or did you understood it? Please write in the chat box if you do not understand this math. Okay, this is very simple. As you can see, this compound which is drawn here, it has a carboxylic acid functional group. So the unionized and ionized form will be the carboxylate ion, unionized will be this carboxylic acid. Now when we take the antilog of this function, so what will happen? Like this fraction is formed. So means the number value less than 1 means the carboxylate ion concentration is less than the carboxylic acid, means the compound is neutral in the stomach. But since the carboxylate ion, this values is greater than 1 in the second case, means the carboxylate ion has more concentration in the intestine. And since carboxylic acid or unionized form of the drug can get a better access to membrane, that's why it is mostly absorbed in the stomach. Okay, yeah, sure, I will repeat it again, no problem. Okay, so as you can see, so in this equation what we use, this part is very important, like the unionized by ionized. So we have two form of this drug, so this is the most reactive functional group, right? This carboxylic functional group. Okay, 1 second, I think somebody wants to join. Okay, so look at carefully. So this medicine or this drug has this carboxylic. So when it is ionized, so what will happen? We will have this carboxylate functional group. Okay, COO minus, and divided by unionized means COOH. Right, the concentration of this divided by the concentration of this term is used in this part. Okay, and the pH is equal to pK plus this log of this value. Okay, so what will happen if this value is greater than 1? If it is greater than 1, what does it mean? It means this concentration of this is greater than this, okay, means that the concentration of the ionized form of the drug is greater than the concentration of the unionized or the whole form of the drug, okay. But if the value is less than 1, so what does it mean? Means if the value is less than 1, means the carboxylate group, means the unionized form of the drug is greater than the ionized form of the drug, okay. So this is the two thing which we have to understand. Now, so in the first stomach case, the pH is 1, so we just put the value of 1 here, and we put the value of pK of the drug 3.4 here. And now what we will do, if you take this 3.4 this side, so what we will have, we will have minus 3.4 plus 1, right, equal to minus 2.4, and it is minus 2.4 equal to log of this, it is equal to minus 2.4. and if you take the antilog of this version of this number, okay, if you took the antilog, so you will get this number. And since it is less than 1, okay, which what does it mean? It means the drug will remain as a whole rather than ionized form. So just look at this, if it is less than 1, if it is less than 1, which means like concentration of COO minus, it is less than the concentration of COOH, and the COOH means this drug molecule which has this COOH functional group, it will remain as this form rather than the COO minus form, okay, as a whole. Since unionized form of a drug can get a better access to the membrane, so it will be absorbed in the stomach, because in stomach it is in the unionized form, but in the intestine this value, this carboxylic acid concentration divided by carboxylic acid concentration is 2.6, means much greater than 1, means the drug will mostly in the ionized form, so it will not be absorbed better or absorbed very good in the intestine, okay. So this was all about your problem. Anyway, when I will share you this PPT, when you try to do it by yourself by writing it a paper, you will understand it much better, okay. So I think it is now clear. So if you have any problem, again, if you don't understand, so did you understood this? So the people who have problem understanding the math, yeah, okay, thank you. So I think it is clear. So this formula in any kind of this question, so these questions are very important, like you may be given some pH and some pK values, and you have been asked whether drug will be absorbed, so this is the only sole formula which you have to use, okay, and that's how you have to solve this kind of problems. Now I will move toward the next problem. So problem number 14, it says that ibuprofen, a weak acid, will be present in the stomach in which form? Number A, ionized form mostly. Number B, non-ionized form mostly. Number C, half ionized and half non-ionized form. And number D, will form aggregate. So as I said, you have to use that formula to understand this, but here you don't have any values, right? You don't have any pK values, but you have one thing, like it is a weak acid. So now try to use your knowledge from the previous problem and try to solve this, like if it is a weak acid, what is the pK should be, in what range the pK should be, and if the pK should be in that range, so is it ionized form or non-ionized form in the stomach, because you know the pH of stomach which we just used in the previous math, okay. If it is a weak acid, so in which range its pK should be, and the pH of stomach you know, and if you use the previous I think formula, so what should be the correct answer for this? So do we have any correct answer? B, non-ionized. Okay. So most of the people are saying it is the B. Okay, let's check out the answer. Very good. So the correct answer is non-ionized form only. So the weak acid ibuprofen, it has a pK of 4.9. Okay, and this is the carboxylate acid group of the ibuprofen, which is the mainly the functional group here. So it is absorbed in stomach and small intestine as function of polarity. Charged and very polar molecules are absorbed slowly, and neutral hydrophobic molecules are absorbed quickly. So in stomach the pH is around 1 or 1.5, and in small intestine the pH is 6. So if you just use the previous math and if you try to solve this, so you will see in the stomach it is formed present mostly as the non-ionized form. Okay, so your answer are completely correct. Now let's check out the next problem. So problem number 15, it says that which of the following medicinal class of compound is not a DHFR inhibitor? Your options are number A, trimethoprim, number B, amoxicillin, number C, pyrimethamine, and number D, methotrexate. You have to identify which of the medicinal class of compound is not a DHFR inhibitor. You just can try to answer this question. I will discuss what is a DHFR inhibitor and what does it do in detail. So don't worry about it, but at first if you know, you can try to answer this question in the chat box. Look at the options carefully. I mean, if you look at the options carefully, I think you can easily answer this question. There is one odd one out option there, so you have to just identify the correct odd one out option. So anybody have tried to answer this? Okay, we have answers like number B. Okay, are the options are not visible? I think the options are visible. Let's check out. Yeah, very good. So the correct answer is amoxicillin. So I have just given you the hint, like to find out the odd one out. So amoxicillin, it is a, what is amoxicillin? So which medicinal class does it belongs? Anybody knows it? If you know, write in the chat box. I will check it later. So what is a DHFR inhibitor? So DHFR is basically a enzyme, okay, which is called the dihydrofolate or dihydrofolate reductase. Okay, and this dihydrofolate reductase, what does it do? It basically converts the dihydrofolate or DHF to the tetrahydrofolate, tetrahydrofolate, okay, or THF. Now what happens, like this NADPH is the hydride source, and this NADPH, it is converted to NADP plus, and this hydride is transferred to this DHF and to make it the THF. Okay, and this dihydrofolate reductase inhibitors are the options are like trimethoprim, which blocks the bacterial enzymes, the pyrimethamine, which is the protozoan, blocks the protozoan enzyme, and methotrexate, it block the mammalian enzyme. Okay, now which I have just given you the hint, like you have to find out which is the odd one out here. So if the odd one out is the amoxicillin. Now I want to know what is in which medicinal class the amoxicillin belongs to. So do we have any answer for this? Okay, very good. It is a beta lactam antibiotic, and it is a antibiotics is also well good. So this is amoxicillin, it is an antibiotic Now it is not a DHFR inhibitor. Okay, so I think it is clear. Now I will move toward the next problem. So problem number 16, it says that which of the following reactions is not a phase 1 metabolic transformation? Number A, reduction of ketones. Number B, conjugation to alcohols. Number C, oxidation of alkyl groups. And number D, ester hydrolysis. So you have to find which of the following reactions is not a phase 1 metabolic transformation. I think what is phase 1 metabolic transformation I have discussed in the first 2 to 3 slides. I have discussed the phase 1 metabolisms in details, and now you have to identify using that knowledge which of the following reaction is not a phase 1 metabolic transformation. Try to answer this question in the chat box. What do you think will be the correct answer? It does not matter if it is correct or wrong, but you try to answer this question. Okay, so do we have any answer for this? Okay, we have few answers like number B. Okay, so many people thinks it is number B. Let's check. Okay, so very good. So correct answer is number B, conjugation to alcohol. So it is not a phase 1 metabolism, and I think I have discussed like in for phase 1 metabolism, the main reaction is the addition of a polar functional group in the drug molecule, which is the phase 1 metabolism. So if you see carefully, reduction of ketones, what does it mean? The ketones will form the secondary alcohol. Okay, and oxidation of alkyl group means alkyl group will form the alcohols, and ester hydrolysis, which again will form alcohol. So A, B and D, so these three options A, C and D, so these all are by the introduction of the polar hydroxyl group. Okay, so which are the mainly phase 1 metabolism, but conjugation to alcohol, it is not a phase 1, it is a phase 2 metabolism, as I have discussed it earlier also. Okay, so as you can see, like this is a R. So if the phase 1 metabolism, the lipophilic group, this epoxide can be formed, or hydrolysis reduction can form this nucleophiles like ROH, RSH, RNH2. In phase 2, what can happen? Glutathione conjugation can happen, or this sulfonation, acylation, or glucuronation can happen. Okay, and this is also a flow chart, like for the compound is highly lipophilic, the accumulation happens, then the phase 1 metabolism happens. After that, it makes the polar, it goes to the phase 2 metabolism, it became hydrophilic, and the excretion, the hydrophilic, it goes directly to the excretion. If it is polar, it goes directly to the phase 2 metabolism, which makes it hydrophilic and then excretion happen. And if it is lipophilic, it directly goes to the phase 1 metabolism, which makes it polar. Then it goes to the phase 2 metabolism, which makes it the compound hydrophilic. Then it goes to the excretion. So these four, so a drug molecule can fall into this four kind of category. It may be highly lipophilic, it may be lipophilic, it may be polar, it may be hydrophilic. If it is highly lipophilic, it will be accumulated and go to the phase 1 metabolism, which will make it polar, and then it will go to the phase 2 metabolism, which will make it hydrophilic, and then it will be excreted. Okay, so this is how the metabolism happens. Now I will move toward the next problem. So problem number 17, it says that identify the incorrect statement among the following. Number A, reduction of the flavin ring disrupted the conjugation. So it is actually regarding, this problem is regarding the FAD system. Okay, the FAD system, FADH, FADH2, the question is regarding to this. So the number A option, you have to identify the incorrect statement regarding the following. So number A is reduction of the flavin ring disrupt the conjugation. Number B, reduced coenzymes are more colored than the oxidized one. Number C, in FAD system all oxidation reduction chemistry takes place in the flavin ring. And number D, FADH2 is the reducing agent. You have to identify which of the following statement is incorrect among the following. So do we have any correct answer for this? Option B. So option B is for what? For this question or the previous one? Okay, let's see. Okay, so let's check out what is the correct answer. So yeah, the incorrect statement among the following is number B, reduced coenzymes are more colored than the oxidized one. Okay, so this is the FADH system. So this is the ring, and this is the FAD, and the FAD, which is converted to FADH2 by the reduction, and the enzyme which takes place in it, it is the flavin reductase enzyme. Okay, now as you can see here, so let's check the options one by one. So reduction of the flavin ring disrupts the conjugation. Okay, so this is the correct answer. So as you can see, it is the flavin ring. Okay, so there is a conjugation. So there is, you can see there is a conjugation here. There is a double bond, single bond, and double bond. So it is a conjugated diene. So what will happen if the reduction takes place, means if this system is reduced, so what will happen? There is a addition of this hydrogen, and there is a one hydrogen here also. Okay, so because of the addition of this hydrogens, what will happen? This conjugation will be disrupted. Okay, so this option is correct. Now reduced coenzymes are more colored than the oxidized one. This statement is not incorrect, because the reduced coenzymes are more. So as you can see, when the this is the oxidized form, okay, and this is the oxidized form, and it is the reduced form. So in the oxidized form, actually what happens, there is a conjugated diene, or there is a conjugation, and whenever there is a more conjugation, means there are more color. So this oxidized form has more conjugation, means it is more colored than the reduced one. So this one is incorrect. Now in FAD system, all oxidation reduction chemistry takes place in the flavin ring. It is also correct. This is the flavin ring, this part, and all oxidation reduction chemistry is taking part in this ring only. And number D, FADH2 is a reducing agent, which is also correct. Okay, so this FADH2, it is a reducing agent in the, when they like NADH, NADPH, it is also reducing agent. So wherever there is a need, so this will give this hydrogen atom to the substrate and get oxidized to this FAD. Okay, so this was all about the FAD. Now I will move toward the next problem. Okay, so it is very easy question. So it is said that which of the following equation is correct for the Henderson-Hasselbalch equation for the weak bases? pH equal to pK minus log unionized drug concentration divided by ionized drug concentration. pH equal to pK minus log ionized drug concentration divided by unionized drug concentration. pH equal to pK plus log unionized drug concentration divided by ionized drug concentration, and pH equal to pK plus log ionized drug concentration divided by unionized drug concentration. In one math previously I have discussed this Henderson-Hasselbalch equation. Now you have to identify the correct form of this equation among these four options. Okay, so I want everybody to try this problem, try to solve this problem, because I have discussed it earlier. So I think you should try to answer this. So I want everybody to try to answer this question since I have discussed it earlier. Do we have any answer? C. So we have, okay, so the previously somebody has answered that it was option B. So yeah, thank you, it is correct, your answer is correct. And for this we have answers like C. Okay, let's check out. Yeah, so the correct answer is number C, pH equal to pK plus log unionized drug concentration divided by ionized drug concentration. So this is the on, you have to check this like for the basic drug and for the acetic drug the equation actually changes. So previously when we have discussed that math, okay, so it was the acid drugs. Okay, acid drugs mean it has a acidic functional group. So for that the for that kind of compounds, the options, the formula will be like this: pH equal to pK plus log ionized by unionized. But for the basic drugs the equation will be like this: pH equal to pK plus log unionized divided by ionized. So you have to just remember the basic form is same, just this ionized and unionized thing, it is just get reversed. Okay, so pH equal to pK plus log conjugate base by weak acid for the weak acid, and for weak base POH equal to pKb plus log conjugate acid by weak base, or it is just other way of writing this. So your answers are correct, so very good. Now I will move toward the next problem. Okay, so problem number 19, it says that low concentration of neurotransmitter dopamine has been implicated in Parkinson's disease, and L-DOPA is the most widely used medicine to slow down the disease. Which of the following statements is incorrect? A. Dopamine cannot cross blood-brain barrier. Number B. L-DOPA acts as a prodrug. Number C. L-DOPA can cross blood-brain barrier. And number D. L-DOPA is first decarboxylated by dopamine carboxylase before entering the brain. Now you have to identify the following statement which is incorrect regarding the L-DOPA, which is a treatment for the Parkinson disease. Okay, and it is, you have to so carefully read the question, carefully read the options, and try to use your knowledge in medicinal chemistry for answering this problem. Okay. So not necessarily every time you get the question in the exams or assignment like which are straightforward. Okay, so you are learning something, you are reading something, and the questions, if you expect that the question will be exactly like what you have read, so it may not be the case for every time. Okay, it may be something, the question may come like this kind of tricky. So but if you read the question and options carefully, I think you can answer this question easily. So take some time, read the question and the options carefully, and then try to answer it. Which of the following statement you think is the incorrect one? Do you have any correct answer for this? Did anybody try it? Okay, option C. Option C I think is for the previous one, right? So nobody has answered this one till now. Okay, no problem. I will just show you the answer and then I will discuss it little bit. Okay, so the correct answer is number D. So this is the incorrect statement. Okay, L-DOPA first decarboxylated into dopamine decarboxylate before entering the brain. Okay, so the first thing is, okay, sorry. So the first thing, L-DOPA or N-dopamine or anything, it cannot cross the blood-brain barrier. Okay, so if it is, so what is a blood-brain barrier? So it is basically a membrane that controls. Okay, somebody I think wants to join now. Okay, so blood-brain barrier, which is basically is the membrane that controls the passage of substance from the blood to central nervous system. It is a physical barrier between the local blood vessels and the most parts of the central nervous system itself and stops many substances from traveling across it. The BBB is the permeable to alcohols and some heavy metals can cross the blood-brain barrier as well. Okay, so for the L-DOPA, so it is the levodopa or the L-DOPA, as you can see from this structure. Okay, now first there is two kind of enzymes, what is COMT, and it will convert this L-DOPA to the 3-methoxytyrosine, and there is AADC which will convert it to the dopamine. Okay, so okay, I think I have made a mistake here. Let me check. Okay, I think sorry, I have made some mistake here. So in this question, what will happen, like this will be I think correct. Okay, I will check this question one more time. I think it will be correct because as you can see, like this L-DOPA, it can be converted to the, it can cross the blood-brain. Okay, so okay, sorry, it is I think it is not, it is incorrect also, because L-DOPA first decarboxylated by the dopamine decarboxylase before entering the brain. So not, it is can itself it can enter the brain. Okay, and then it is converted to the dopamine by this enzymes. Okay, the enzyme is AADC, and then it is the MyoB which converts this dopamine to this DOPAC. Okay, so this the other options which are correct. Okay, so one by one I will discuss it. So dopamine cannot cross the blood-brain barrier, so it is correct. Dopamine itself, it cannot cross the blood-brain barrier. L-DOPA, it act as a prodrug. Okay, it is also correct, because L-DOPA, it is converted to dopamine, which is the main actually your main drug system or main medicinal system, which is the dopamine. But since dopamine cannot cross the blood-brain barrier by itself, so it is L-DOPA which is given as a drug, which is the prodrug, which is converted to the dopamine. Okay, so L-DOPA can cross the blood-brain barrier, it is also correct, and this one is incorrect. L-DOPA is first decarboxylated by the dopamine decarboxylase before entering the brain, so it is incorrect, because L-DOPA itself enters the brain by crossing the blood-brain barrier, and then it is converted to the dopamines. Okay, so this was the incorrect statement. Now for the last question, I want everybody to try it again. So which of the following correct decreasing order of the drug metabolism? Okay, so the options are number A, liver, greater than lungs, greater than kidneys, greater than intestine, greater than placenta, greater than skin, then adrenals. Option B, liver, then lungs, then kidneys, then intestine, then adrenals, then placenta, then skin. Number C, liver, kidneys, lungs, intestine, placenta, adrenals and skin. And number D, liver, lungs, intestine, kidneys, placenta, adrenal and skin. So you have to identify the correct decreasing order for the drug metabolism. Today the main topic was about the drug metabolism. We have discussed many things about the drug metabolism, the phase 1, phase 2, where the phase 2 takes place, how the excretion takes place. Now you have to identify the correct decreasing order of the drug metabolism. So do we have any correct answer for this? Okay, number C. Okay, let's check out. Okay, so the correct answer will be number A. Okay, let's see. Okay, so the drug metabolism, it is not the number, I think number C, so it is the number A. So first, as you can see here, it will be liver. Okay, the schematic chart. So liver is the heart of the metabolism because its relative richness of enzymes in a large amount. So the schematic chart for the metabolizing organ decreasing order will be liver, greater than lungs, greater than kidney, then intestine, then placenta, then skin, then brain, testis, muscle and spleen. Okay, or we can see the adrenals as a whole. So this is a flow chart of the drug metabolism, like the drug is administered, then the absorption happen, then the distribution happen, then the drug metabolism happens and elimination also happens, and for the distribution, transfer of the in situ inside of the action, regulatory proteins are there, then the affinity, the binds the molecular target, the mechanism of drug action, the response of drug, which is the efficacy. So it is the first part which we know as the pharmacokinetics, and the second part which we know as the pharmacodynamics. So the correct option answer will be number A. Okay, the first it will be liver, then lungs, then kidney, intestine, placenta, skin and then adrenals. So this is it. This was all the 20 questions which we discussed today, and it was your okay. So today we discussed about 20 questions regarding your week 6 course content, and today it was the week 5 live interaction class. So we discussed 20 questions regarding the drug metabolism mainly, and this all slides, PPT and the questions, everything will be shared to you, okay, by the NPTEL website. The recording of today's class which we did, okay, from which book I have yeah, obviously you can get this slide. Okay, so as I said, like every day we just share these things like these slides and this lecture videos to the NPTEL site, and they will communicate to you the slides and this lecture video also. So in any case you have actually missed something during the class due to the poor internet connection, so you don't need to worry, the recording will be given to you and along with this PPT. And the books, actually I actually take some questions are from your previous year assignments, so for this course, and some questions are half of the questions from the previous years generally, and half of the question I try to check out from many medicinal chemistry books. So there are many actually standard medicinal chemistry books. Okay, so I take some questions from there also, and mainly something from your lecture videos also, like after checking out the course contents everything, I try to make some questions in between. So if anything which you missed during the sessions or anything, you can just try to recapitulate from seeing these questions. Okay, so anyways, today it was the week 6 course content questions, and next Saturday it will be your week 6 live interaction session where we will discuss your week 7 class materials. Okay, and I think I thank you for joining today's class, and like every Saturday we will have this kind of class, and from 6 p.m. to 8 p.m. and I request you all to try to join on time. Okay, by 6, if the class starts from 6 p.m., try to join by 6:05 to 6:10, and also try to answer the questions as much as you can. It does not matter if the answers are correct or incorrect, but if you try to uh, answer, it will be better for you too. Okay, so I think I can just close the session for today. So I thank you all. I hope you like the class, and I will just again, yeah, please send by email. Okay, so I cannot send you by this slides by email. Okay, so there is a protocol. Every slide and everything, it will be communicated to you by the NPTEL website. At the end of the class, every time we the TAs of the class, we share it with the NPTEL. What I can do, I will just request the NPTEL to update these slides and the lecture videos to the students, so that they can check it out. So I will just do that thing. I will request them to update it as soon as possible, so that you can check it. Okay, so I think in the NPTEL website it will be updated soon. Okay, so the lecture videos and the slides also. Okay, so thank you all for joining today's class. So let's see you in next week. Okay, I think I can stop presenting right now. Okay, so see you in the next Saturday. So thank you.